friends, in this video series I have discussed about types of grounding. In that we have seen about system grounding and equipment grounding and ungrounded system and solidly grounded system, and today we are going to discuss about resistance grounding system. Let us get into the topic. What is this resistance grounded system? Let us have a small recap. What is a solidly grounded system? In a solidly grounded system, the neutral point of a three-phase system is connected to earth with a minimal resistance path, or you can say a pure conductor is used to connect a neutral point of a three-phase system to the ground, so that during fault condition the current which would flow in this path will be very high. So this system is called as solidly grounded system. Because of this high current, there could be a mechanical stress or electrical stress, and damage would happen to the insulation and to the conductor and other devices which were connected in this electrical power system. So to avoid this problem, or to limit the current during this fault condition, so this is achieved either by inserting a resistance, or you can also insert a reactance. So in this particular video we are going to see about inserting a resistance in a ground path. So this resistance value will determine whether it is a low resistance grounding system or high resistance grounding system. Also it determines amount of current which should flow in the faulty condition. Okay, so how much current would be allowed during the fault condition? Based on that you would select either it is a low resistance system or it could be a high resistance system. So anyhow, the resistance grounding system is used to avoid or used to reduce burning and melting effect in the faulted electrical equipments, because it is going to reduce the fault current so that it can safeguard the switchgear, transformer and cables, rotating machines like generator machines and motors from this burning or melting effects. And also the mechanical stress or the electrical stress can be avoided, and the electrical shock hazards because of the stray ground fault current. So because of this high potential strikes from the lightning and high potential surge waves created during the turn on and turn off of this grid or the capacitive banks and this kind of things, no? So because of that there could be a high potential difference between the neutral point and the ground, and because of that it would create a charge discharge from the neutral to this one, and the charge accumulation on the earth would create a problem to the person who is coming near to the device. And also it reduces the arc blast or flash hazards to the person who is working in the device or who is near to the device. Okay, so because of the high current or high amount of current during the fault, it could create a arc or it could create a flash. So this would be a very dangerous situation for the person who is going to work there. So the current is going to be limited so that this effect also can be restricted. So let us see what is a low resistance grounding system. In a low resistance grounding system, the fault current would be limited to 200 to 400 ampere. The resistance would be selected in such a way that the fault current would be limited to this. So because of this fault current limitation, so you would reduce the arc flash hazards and phase to ground arcing conditions, and the mechanical damages and thermal damages due to the short also can be reduced. And the overcurrent devices during the fault would open because the current still is higher, so it will open the overcurrent devices. No need of having a ground fault detection system in case of a low resistance grounding system, because overcurrent devices can identify the fault and it would open the system. HRG system, that is a high resistance grounding system. In this case, the current would be restricted furthermore, and the current would be limited to 5 to 10 ampere. So the resistance which is inserted would be little more value, so that the current would be restricted to a very less value. So again the advantage, further the arc flash hazards can be reduced, and then phase 2 ground arcing current also can be reduced. The mechanical damages can be reduced and the thermal damages also can be reduced. And now the overcurrent device won't be having enough current to open the circuit, so we must have a system ground, so the grounding equipment should open the system during the fault condition. Then the high resistance grounding, where I can use this, we can use the system where the immediate isolation is not required during the fault condition. And when a ground fault occurs, ground fault current continues to flow similar to a solidly grounded system, but typically restricted to 10 ampere or less by the neutral grounding resistor, so that is called NGR. Right. So the system would be like this. Here you can see the system, three-phase system. Neutral point is connected to the earth potential point with the NGR, which is a neutral ground resistor. And in the other side, in the equipment side, the equipment grounding also done here. So the typical values of the resistance is shown here. So this equipment to ground conductor value 0.1 ohms is shown here, and the ground resistance is maintained as 0.2, and then here the NGR value is maintained 55 ohms. So we can see how much current would flow during the fault condition. You can see here the formula is given in this way. The single phase voltage, the line to ground voltage is given 277, and the resistance for the respective places, resistance value at a point of fault, and resistance of ground return path, and resistance of neutral grounding resistor. So all this summation will be giving the total resistance. So the current is limited to 5 ampere. So that's why we call this as a high resistance grounding. So the current would be limited. So during this faulty condition, how much power is dissipated is this much, 2.5 watts. It is very much limited. And in this system, we need to keep the NGR intact and also the equipment grounding conductor proper, so that the system would function properly. So we have to monitor this NGR resistor, as well as we have to monitor this conductor here. So if these two are working properly, so that means the earthing will be proper. So for that we have two different devices. One is ground fault ground check device, then another one is a the device which is going to check the NGR condition. So first we will see what is ground fault ground check condition and why it is needed. This ground fault ground check device is required to monitor the conductor from the equipment to the ground, it is intact or not. Why we need to check this? If this is open, what will happen? So if this path is open as shown here, so this will become like a ungrounded system in the load side, and because of this here high potential will be there in case of fault. When the human being comes in contact, the touch voltage will be very high and the discharge will be very high, and because of that the human will be in very high danger. So we need to always monitor there is a path provided for the fault current. So for this purpose we are going to have this device. So here we have a CT. So this CT is going to monitor always the line currents L1, L2, L3, and if it is equal, that means there is no fault and it is not going to give any signal. So this is the main role or the first role of this ground fault ground check relay. And the second function is to monitor this conductor healthy condition. So this is going to be achieved by giving a small DC signal from here. So this DC signal will be sent to this, and if the path is closed, then the resistance would be very less in this condition. So in case if the path is broken, then the resistance would be very high, and this resistance condition, the low to higher resistance condition will be compared, and this will open, or this will give the signal for the the operator or whoever the responsible person for getting this responsible person for removing the fault. And in case of a short circuit, the conductor from this device is shorted to the earth. This also will be detected, so that it will provide very less resistance here. So because of this low resistance for the signal which is given here, the more amount of current will be drawn from here, so that this also will be identified by this relay and this relay will give the respective signal. So this is how the path will be identified, and it will be always under the surveillance of this particular device. So first one, it will check whether there is a ground fault using the CT, and the second one, the DC signal is given to this one, and the resistance is always monitored through this ground check termination device. And if the resistance is high, that means the path is open here, and if the path is open, that means it is going to give the signal to the relay, and the relay will either it will give the alarm or it will open the circuit according to the connections. And if the signal is not reaching to the ground check termination device, and it is drawn more current from the relay, this particular device, that means it is also going to say that there is a short circuit, ground check short is there, so that it will give the indication and it will give the open signal. So this is for ground fault, ground check circuit. And the next one is a ground fault NGR monitor. So this NGR monitor is for the system grounding side, so this side. So here we need to monitor again two condition, whether there is a fault current. So the fault current would be identified by this CT, and the CT, whenever there is a high voltage or high current passing through this particular line, so this CT will identify the current and it will give the signal to this device, and it will take the necessary action. And the second one, need to monitor the healthiness of this resistor, whether this is having a proper resistance, and also we need to see whether the loop is closed or open. So you see here, this is open, so this is a faulty condition. In some case, the resistor after long usage or something like that, the resistor would short like this. This short circuit is not a good condition, as well as this open of the connection also is not a good condition. So both condition need to be identified. In case of short circuit, the system will behave like a solidly grounded system. In case of open here, or the open circuit here, the system would behave like a ungrounded system. Both are not a good case for a system which is defined to work in this resistance grounding system. So here we have the CT. As I told you, the CT will identify the current, fault current, and it will give the signal. For identifying the resistance condition, we have this CD series coupling device. So this device is going to monitor the resistance of this loop. Say this loop, it is like this loop. Always it is going to monitor the resistance of this loop, and in case if the resistance is appropriate, so if this is connected and this resistance is, say for example 55 ohms, it always going to have this small value of resistance. So that means there is no problem in this. In case if there is a short circuit, so this 55 will change to a smaller value, say 5 ohms or 10 ohms like that. So that means this condition is not a normal condition, so there is a short circuit. Or if there is open, so this 55 will change to infinite amount of resistance or infinite amount of resistance. So this also can be identified. So and this particular relay, the NGR monitor relay, will give the respective notification, either it is a low resistance, yani it is a short circuit, or if it is open, so it will show high resistance, so that particular LED or that particular alarm will work. Or in case of the fault current flowing, the CT will detect and it will give the respective alarm or signal. So this is to monitor the fault current in the system grounding side, as well as it is the way to identify whether the NGR is properly connected to the ground or not. Okay, so this is about NGR monitoring. So what are the applications of this HRG application system? So mostly used in mining and mineral processing, petroleum refineries and sawmills, petrochemical facilities, pulp and paper mills, factories, pipelines, food processor, natural gas processor. So these are the few applications of this HRG, that is high resistance grounding system. Hope it is clear, and in case if you have any doubts, please let me know in the chat box. Thank you. Thank you so much.